Welcome to week 3 of six weeks. We're going to work on simplifying radicals. Please understand that everything we do this week is the foundation of what we're doing next week. If you don't understand how to do it this week, you're going to struggle next week, so pay attention. We're going to break it down for you. Alright, so we're going to simplify radicals using multiplication and division. You can add and subtract radicals. We will not be doing that, so the characteristics that come with that won't apply. So first off, you have to understand what perfect squares are. When you multiply a number by itself, you get a perfect square. So 1 times 1 is 1 squared, gives you 1. 2 times 2 is 2 squared, gives you 4, and so forth. On the bottom of the screen, I've listed the perfect squares from 1 squared to 15 squared. You can pause the video and write those down and look at the examples up top, but most of these you should know. So we want to simplify radicals using multiplication. That's the easiest method first. So if I have a number times another number under the radical, I can simplify that. So with these, I'm getting those perfect squares. If they were a perfect square, then when I simplify them, I get what's called the square root. I get that number that was multiplied by itself. So with the perfect squares, it's pretty easy. This is the reverse of that previous slide. But if you multiply a number times a radical, it's similar to multiplying a number times a variable. Like 4 times x gives you 4x. You just slide the 4 next to it and it becomes its coefficient. So 5 times radical 11, or square root of 11, you can say either way. You would slide the 5 next to it and get 5 radical 11, or 5 square roots of 11. Again, both of those are correct. Same thing with the 3. Slide it next to it. But here I put that 2 in the back instead of the front, so when I simplify, I need to bring it to the front. Just as if like the radical 11 was the x, it has to be second. You'll have coefficients that are the whole numbers or fraction, the radicals, and then you would have variables. So back to what we said before, if I have a radical times itself, and it was the same radical, I'd have a square number, so I got the square root. So the quick way of doing that, instead of writing all these steps in between, is if you see the same radical underneath the radical, the same number underneath the radical twice, then you cancel it and you pull it out and write it once. So I have 2 7s, I cross them out and I write it once, because the square root of 7 times 7, which is the square root of 49, is 7. So you should be able to jump straight ahead to that. So now you're going to have 4 questions that you're going to use for the answers for number 1 through 4 in your all-in learning. Pay attention, write these answers down, because pieces of them will be the answer. So now if I have a radical times a different radical that's already simplified, it's easier. The next problems will be when you have to simplify. So here, it's all multiplication. This is like saying 4 different things are being multiplied. I'm going to pair up those coefficients, 2 and 4, and I'm going to simplify that part first. Then I'll pair up what's under the radical and simplify those. So the way you say it is radical 11 times radical 5 is equal to radical 11 times 5, which is equal to radical 55. Same here. The 3 times 4 is 3 times 4 is 12. Radical 10 times radical 5 is radical 10 times 5, which is radical 50. You can pause and look at these other 2 examples. They are exactly the same. I'm not going to go through those. But you probably have to go back to that screen and pause it. And to show that you've watched this video, tell me what the number was inside the radical for 1, outside for radical 2, inside the radical of number 3, and outside the radical on number 4. So here those are again: inside, outside, inside, outside. That's the end of video 1. And now be prepared to answer questions for video 2. So now we're going to get a little more complex. The next video is going to go with the next 4 questions. So you got 4 questions. It's going to be number 5 through 8 in all-in learning based on what you learned in this video. Please pay attention, and if you need to pause or replay the video, you have that option. So radical times a radical that can be simplified makes you take another step. So in this problem, looks similar to what we just did before. The 2 times 4, the coefficients outside. We'll group those together. 2 times 4 is 8, and we'll bring that down until the next to last step. But this radical 6 times radical 3, I'll pull together and have radical 6 times 3. And when I simplify that, it's radical 18. Make sure you leave the radical symbol until you have taken a square root. But then I look at my list of square numbers and I say, what is the biggest square number that goes into 18? Well, 9. 9 times 2 is 18. It's still under the radical, so everything in blue is equivalent. So when I see a square number under the radical, I take the square root and pull that number out. So I have 8 times 3 because the square root of 9 was 3, but that 2 is stuck by itself under the radical. So now I get 24 radical 2. Similar with this one. The 3 times the 4, I pull those together. I get 12. Pull that down to the next to last step. But that radical 8 times radical 6, I'll pull them inside together and get radical 8 times 6, which is radical 48. If you remember how to use prime factorization, where you would have 2 times 2 times 2 times 2 times 3, you can do that. But I would want you to kind of boost your mental math level here and figure out what square numbers are factors of 48. And if I know that 16 is a square number, I can just take the square root of it and pull that out, which is 4. Then when I simplify, the 12 times 4 gives me 48, and that 3 stayed under the radical. It was by itself. Take a moment and look at this problem. Same thing. And then take a moment and look at this problem. Now, I'll explain number 8 because it's different than the other 3 problems. I factor the 14 and it's just 2 times 7, no square factors. I factor 21, it's 7 times 3, no square factors. These are actually all prime numbers, but 2 of those are the same. So when I put it all together, I really did have a square number that was a factor of the big product because 49 was a factor. And the square root of 49 is 7, so I take the square root and pull it out in front of the radical. That 6 can't be broken down, it stays underneath. Make sure you wrote these down. You're going to have to come back and look at these because these next questions are a little more specific. So, in step 4 of number 1, we multiplied 2 times what number under the radical? Well, let's go. 2 times 9. And actually it's number 5. Sorry about that. What was the number inside the radical for number 2? Well, that's actually a number 6. So the number in the radical is 3. What was the number inside the radical for step 3 of number 3? Step 3 is right here. That number inside the radical is 72. And finally, what was the number we factored out of both radicals in number 4? Well, that was a 7. So I hope you wrote those down. That was the end of video 2. And now you're going to have your last video with another 4 questions. And after you complete this, you will have your weekly homework assignment. Okay, finally, the start of video 3. Now we're going to be dividing. This is where it gets a little tricky. We're going to simplify radicals using division. So please watch this process. I'm going to show you a shortcut, but this is key in Algebra 2. This is something you will use next year. Please don't just forget it. Some of you that are a little stronger in math or maybe pre-AP, you're going to want to learn this now. It's going to be actually pretty easy for some of you, but just work with me here. So when you multiply by the number 1, you get what you started with. So anything times 1 is just that number. But anything divided by itself gives you 1. So we're going to use the denominator of these fractions that have a radical to make the number 1. So we have a number to multiply by that is 1. Radical 5 over 5 is equal to 1 because it's something divided by itself. So for this particular problem, I have 6 divided by radical 5. So I'm going to multiply it by 1, which is radical 5 over radical 5. When I simplify, I'm multiplying straight across. 6 times radical 5 is 6 radical 5. Radical 5 times radical 5 is radical 5 times 5. The numerator still stays the same, but 5 times 5 is 25. Well, that happens to be a square number. So the square root of 25 is 5. And my final answer is 6 radical 5 over 5. If you look at the beginning and the end, you still have a 6. But that radical 5 is now in the top of the fraction. And you have a 5, which was inside, in the bottom. So here's your shortcut. You have a radical in the denominator. Instead of going through all those steps we just showed, now that you know it works, you're just going to slide this radical to the top of the fraction and pull the number down. Slide the radical to the top, pull the number down. Slide the radical to the top, pull the number down. Slide the radical to the top, pull the number down. The first 3 problems, you couldn't simplify. They were done. But the last problem you actually can, because 9 and 6 are multiples of 3. 9 divided by 3 gives you 3, and 6 divided by 3 gives you 2. So your final answer is 3 radical 6 over 2. So if I have a radical divided by a radical, but then I have something in the top, I'm going to multiply. I'm going to do several things. I'm going to be multiplying by a reciprocal, factoring. It's a lot of things. So I want to use color again to help simplify this. Okay? So if I divide by radical 6, I'm going to use that trick we just said. Slide the radical to the top, pull the number out. Well, what I did over here was I took that radical 6 and I factored it to 2 times 3. Because remember we said if we see the same radical twice, we can get rid of it and write it once outside of the radical. Everything else stayed the same. So now I'll simplify. The 3 and the 2 is 6. In the denominator is 6. The radical 3 stays. 6 divided by 6 reduces to a 1. And your final answer is radical 3. Same here. I have radical 12 in the numerator and radical 8 in the denominator. Slide that radical to the top. Pull that number down. I want you to see in the green that the number I had before was not simplified. So I factored it. And when I factored that radical 8, I noticed I had a similar radical. So remember, we see the same number under radical being multiplied. You cancel them and write them outside without a radical. But up top, I was left with a radical 3 and a radical 2. Those multiply to give me radical 6. The 10 just stayed up there. So now when I simplify, 10 times 4 is 40, and the 8 slides over. Radical 6 is still there. 40 divided by 8 gives me 5, so my final answer is 5 radical 6. We're almost done. So now if you see a radical in the numerator and denominator, but you notice, hey, those have common factors, I could reduce those. You can pull them together under the same radical. And if they reduce to a whole number, you just made your job way easier than pulling to the top and multiplying and all that stuff. If it simplifies, simplify it. 14 divided by 7 is 2, so radical 2, and we're done. Similarly here, I have a radical 8 and a radical 24. Well, I know 8 actually goes into 24, so 8 is a factor of itself and 24. So I pull that together and get radical 8 over 24. Reduce it and I get 1 over 3. The square root of 1 is just 1. So if you see a fraction under that radical and 1 is on the top, it's super easy. It's like the 1 was never there because anything times 1 is just that number. So I'm going to pull that 3 to the top. Slide it to the top and pull that 3 below. I showed you here that when I take the square root, I get a 1, but you shouldn't write all these steps. You should be able to go from here to reduce it to this step. Then you realize there's a 1 in the numerator. Take that denominator, pull it to the top, slide it out. Or slide it to the top, I'm saying it backwards. Pull it to the bottom. So now you got 4 questions that you answer based on that video, and then click those answers in. So Radical 72. I'm going to jump ahead and say there is a way to work backwards. If the square root of this is my answer, then the answer squared should give me this number. Well, we know 2 squared, that's 2 times 2, gives me 4. That can't be it. 12 squared is 12 times 12. That can't be it. But 6 radical 2 squared would be like saying 6 times 6, which is 36, and radical 2 times radical 2, which is 2. So 36 times 2 is 72. Over this one, 98, I'm going to actually break this down like we did before. And I look at my list of square numbers and say 98 is 49 times 2. That would still be under the radical. Well, 49 is a square number. The square number of 49 is 7. It's one of these. But I just said it was 49 times 2, so I still have a radical 2 underneath. Number 11, radical is only in the denominator. Slide the radical to the top, pull the number down. So the radical is on top, the 21 is on the bottom. You cannot reduce 4 and 21. That's your answer. And then this last one, you have a radical over a radical. Well, I can reduce 100 over 500 and get 1 over 5. So that's a big radical 1 over 5. Remember when we have the radical on the top, that's a 1. You're just looking at the number in the bottom. So take that radical 5, slide radical 5 to the top, pull a 5 down, and you get B as your answer. So your answers are B, A, B. Those are the questions. And when you're done with these, don't forget that everything that you learned this week, you need for next week. We'll be covering special right triangles, a 30, 60, 90, and a 45, 45, 90. And as you can see, there are radicals on the sides. So now you should be able to complete your Quizizz assignment for this week. It's 20 questions. Let's go. This is the end of video 3.